we remember that inverses, first of all, they have to be functions, so they have to pass the function test, which was everything relating to the x couldn't repeat with a different y, the y couldn't be an absolute value, the y couldn't be squared, and the vertical line test, right? That was all the function test. Then we got into the inverse test, which is that now it's a horizontal line test. It's an x can't be raised to an even power or an absolute value, and the y can't repeat with a different x. So number one, it says that the function have an inverse. This would fail a horizontal line test, so this is a no. Number two would also fail a horizontal line test, so this is a no. Number three would pass, and this is a yes. So remember, does have an inverse is the same thing as 1 to 1. Those mean the same thing. 4 and 5, we just said the x can't be raised to an even power. The x can't be an absolute value. So 4 does not have an inverse because the x is raised to the 6th, and 5 does because the x is raised to the 5th power. Then 6 says find the inverse of the function. So our first step is to substitute the y in for the f of x. Switch the x's and the y's, and then solve for the new y. So x minus 5 equals 2y, and y equals x minus 5 over 2. Last step, make that an f negative 1 of x because it is no longer f of x. If it was like this, for an answer that works unless I have to graph it, and that would be a 1/2 x minus 5/2. So just keep in mind both of those answers would work if it's just looking for the inverse, but if it is asking you to graph it, then you'd need to go to the next step and split it. All right, so speaking of graphing, this was number 10 in the homework. It said to use the graph of the function to complete the table. So if this is my original f of x, then I want to take each of these points and switch them, switch the x and the y to get the inverse function. So if I switch this, it's 6, negative 4. If I switch this, it's 0, negative 1. If I switch this, it's negative 2, 3. And the last one would be negative 3, 4. And then from there, I'd plot my coordinate point, so it gave you the little grid, but if you did it on like Notability or in a notebook, then I would get 6, negative 4, 0, negative 1, negative 2, 3, and negative 3, 4. And my graph should have looked something like that, okay, which is the inverse of my original graph. Questions? Okay, so we're going to get into in just a minute, okay, which is quadratics, but I wanted to say about the test. So I published your grades for the test and the feedback for the test. So I want you to go back in tonight and check your answers, okay? I will post in the directions of the test the solutions for the graphing question. So I'm going to put the PDF with the solutions for the graphing questions right there in the body of the test so that you can kind of compare, because there's a lot of things I tried to give a little bit of credit for. If it was a rounding issue, but it was like within the nearest 10th, I gave you back the credit, but I put it in the notes. If you were way off, obviously that was an issue. If you didn't put it in the right format, remember that intercepts were supposed to be in coordinate points, zeros are supposed to be listed, that kind of stuff. You may have lost a little bit of credit. And then parentheses and brackets, you would have lost a little bit of credit. But I did try to give back some of the credit on that one. The rest of them, the answers should either be in the feedback, or if it was one that was like a file upload question, I tried to comment specifically what you got wrong. So if it was the circles and your r squared was wrong, I put it in the comments. If it was like your graphs and it was supposed to be stretch and you didn't do that, I put stretch. If it went to the left instead of the right, I put should go to the right. So that kind of stuff I try to put directly in the comments on the feedback. So please take the time. You don't need to do it now because we need to do some notes. But please take the time this evening to look back through those tests. Some of them were great and some of them were not great. If you're in the not great area or you didn't get what you thought you should get, you've got some work to do moving forward. Whether it's stop relying on your notes so much, because I'm feeling that's some of it, which is killing your time. You need to kind of start to pretend that this is a regular test in which you don't have notes so that you can train yourself to not need those notes, okay? Hopefully I mean, the stuff in this chapter also takes a while because it's complete the square, graphing quadratics. Like this stuff takes a while too. It's not like these are fast questions. So you need to make sure you're watching your time. I would tell you that in the normal classroom environment, you would have had more questions and less time, because from the time you walk through the door, take attendance, and get a test in front of you, you're normally looking at a 45-minute test. You had 50, and I normally would have given more questions. I cut back. So just think that that's time. If timing is your issue, you got to work on it, okay? Because I'm not gonna make it less questions. You need to make sure that you're, one, more prepared, so you're not going back and forth between your questions. Two, not relying on your notes so much, okay? Okay, Sophia, I'll have to deal with that at the end. Okay, so when I jump off, just remind me, okay? Matt, I did get your email. If your Wi-Fi kicks out, don't worry about it. And somebody else emailed me this morning. I forget who it was. I'll look at it later. Okay, I will reply to them. I'm not ignoring them. All right, so 2-1 is quadratic functions. You're going to spend more time on parabolas than you ever thought you really wanted to spend, okay? We're going to do a couple of things in this section. One, it is completely narrowing it down on a function, so you're going to see a lot of f of x, and then also a quadratic function. So we're talking parabolas. We're going to learn how to take a graph, make it very specific, not just like a transformation graph. Talk about max-min like we did before, but this time it's absolute max-min. Talk about domain and range, and then we're also going to take equations that are not in standard form, put them in a standard form, and learn the difference between that and quadratic form. So quadratic functions, okay, are functions that have x squareds in them. This form right here is called quadratic form. And that is, you have an x squared and you have an x. The a is in front of the x squared, the b is in front of the x, and the c is the constant that's by itself. Obviously, we know this to be a parabola. It is shaped like a U, and it is symmetric to a line called your axis of symmetry. So it's also going to ask you to identify an axis of symmetry in this section. Here's all the parts of the graph of a parabola. So I'm going to zoom in on the one on the right because that is, well, not all the way because I don't want to get cut off. That's the one that's positive. That's your standard one, okay? Obviously, it's a U. This one's at -1, 0. It could be anywhere, okay? The point where it changes direction is not only a minimum point, but it's also your vertex. The axis of symmetry runs vertically through that point, so it's a vertical line. On a parabola that faces down, the vertex is at the top, which is the maximum. The axis of symmetry still runs vertically through that vertex. So you'll ask for the vertex, which is the coordinate point. You're going to ask for the max or the min, which is just a single value. It's the y coordinate. You're going to get asked for an axis of symmetry, which is an equation, and x equals, okay, which we're going to kind of get into each of those.
Can you go back up to the first?
All right, if your a is up greater than 0 so that it is positive, it is a parabola that points up. If it is less than 0 so that it is negative, it's a parabola that points downward. When it's in standard form, I would say that that's the first thing that you should be able to look at. First of all, you got to know it's a parabola. Then you got to go, does it open up or does it open down? Okay, so we're going to go back to what we know about graphs, which is how to plot points. So this is one way to do it. Should you know nothing about this graph, then I can simply plot points, right? So based on what we just talked about, I know that this is positive, which means this is a parabola that opens up. Those two things, hopefully you already know. So let's plot some points. I'm going to plug in like -1, 0, and 1. If I plug in -1, I get 2 times 0 squared, which is 0. If I plug in 0, I get 2. If I plug in 1, I get 8. Negative 1, 0. 0, 2. 1, 8. So now I know this is supposed to be a parabola, but I only have one side of that, which means I have to know enough to plug stuff into the left. Because you know transformations, you should remember this is a left shift to the 1, which means my vertex is here. You need a vertex and points on the right and to the left of that vertex. So I'm going to take and plug in negative 2 because I need the curve to go back up on the other side. And there I know it's going to go back up. Now these are symmetric. Every point that happens on the right-hand side is going to happen on the left-hand side. So I know if I went up and left 2 on the right, it's going to happen. If I went up 8 and right 2, I can go up 8 and right left 2, and I know the other coordinate point is there. So these are symmetric to the not the x-axis, to the axis of symmetry. Everything that happens to the right of my vertex is going to happen to the left of my vertex. So that's probably the last time we're going to plot points like that, okay? But I go over this because when in doubt, if you don't know what your graph is going to look like, plot yourself some points. What is it? X. All right. Our second form is called standard form. And in this form, which is what we use for transformations, the X is inside the parentheses or it's just squared. You don't have an X and an X squared. So think about all the things we talked about with transformations. The number on the front, that's what makes it narrow or wide. The one on the inside is your shift left to right. The one on the outside is up or down. It's the same. Your vertex is HK because that's your X shift and your Y shift. And your line of symmetry is X minus H. So if I had f of x equals 2x, like I go back to the one we just plus 1, squared. This doesn't impact my vertex or my line of symmetry. The plus 1 means my h is negative 1 because it's always the opposite sign. There's nothing on the outside, so that'd be plus 0. That means k is 0. So my vertex is negative 1, 0. And my axis of symmetry is x equals negative 1. So those two pieces of information I can get just by looking at my equation, if it's in standard form. And I would know it's a parabola that points up by looking at my A. So all that information you can get just by looking at your equation, okay? The x coordinate of your vertex is always the opposite of what follows x. The y coordinate of your vertex is the same sign that's in your equation. That does not change. So when we do circles and stuff like that, we do the opposite. When we did algebra 2, this was our standard form because it's not a function yet. So that's the standard form, and so we do the opposites of. You're going to see these in function form, and in function form, the k is going to be on the side with the rest of it, which means it's already the right sign. All right, so if I have an equation in standard form like we just did and we don't want to plot the points, we're going to determine if the parabola opens up or down from the A. We're going to find the vertex. We're going to find intercepts by plugging 0 in for x and 0 in for y. And if that's not enough information, we're going to plot some additional points.
Ms. Christweiser,
yes.
Can I ask a nitpicky question?
Yes.
Can you go to this slide?
The one before this?
Got it. Thank you so much.
You're welcome. All right, so let's look at it now that we just talked about what we talked about. First of all, we know it's a parabola, and the negative on the front tells us which direction is this pointing. Down. Good. So this is a parabola pointing down. My vertex is the opposite of what follows x, which means -2, and then whatever's next to it, which is +4. My axis of symmetry is x equals the h, which is -2. So I already know -2, 4 is my vertex, and my axis of symmetry is going to run right through here. And then it points down. Now I'm going to do my intercepts. So my y-intercept is the easiest one. I just plug 0 in for x. I get y equals, because f of x is the same as y, -0 plus 2 squared plus 4. Y equals -2 squared plus 4. I have to square the 2 first, so it becomes 4, then take the negative, which means my intercept is actually at 0, 0. Now that means one of my x-intercepts is 0, 0, but there could be another one. So I'm going to test it by saying 0 equals -x plus 2 squared plus 4. So plug 0 in for the y, subtract the 4. Divide both sides by -1 or multiply by -1, I get 4 equals x plus 2 squared. Square root both sides, putting a plus and minus in front of that 4. I get plus and minus 2 equals x plus 2, which means 2 equals x plus 2, and -2 equals x plus 2. Subtract the 2, and there's my 0, which I knew was coming. Subtract the 2, and I have another intercept at -4. Which should make sense, right? If this is symmetric and I went right with the one intercept, I should go left with this one. If you have a vertex and a point on the right and a point on the left, you have enough, from your intercepts, you have enough information to plot your graph. You don't need to plot any more points. I just draw my graph, okay? So 3 points is enough, but it has to be the vertex and 1 point to the right and 1 point to the left. If there wasn't 3 points, then I would have plotted a point to the left of my axis of symmetry, or the left of my vertex, because I already had one to the right. Questions so far? So I would recommend that same pattern every time. Identify whether it opens up or down, find your vertex, find your axis, find your intercepts. If it's not enough information, plot some additional points. All right, you try this one. How does it face? Find your vertex, find your axis, find your intercepts. All right, so hopefully you got something like this. Well, not something like this, but pretty much this. Okay, your vertex, first of all, it points up because it's positive. Your vertex is at +3, -4, which means your axis of symmetry is at x equals 3. Your y-intercept, if you plug 0 in for x, you should have gotten 5. And your x-intercept, if you plug 0 in for y, you should get 1 and 5. You don't need to go like to do the reflective point off of the y-intercept, but if you did, that's okay too. So from my vertex, I would have gone up to 5 and then out 3 spots. Okay, you could have plotted that, but you didn't need it because you had enough information from the 3 points of your intercepts and your vertex. Questions on this one? Okay,
This is symmetry you just get from the equation itself.
Yep, it's
right?
x equals whatever the x-coordinate of your vertex is, the h. You are going to get problems in which when you go to square root here, that number's negative, which means there's no x-intercepts. A parabola could do this, or a parabola could do this, okay? That's going to happen, and when that happens, that's when you have to plot some additional points. All right, so the next part of this is complete the square, which is something hopefully you learned in Algebra 2. We're going to do it a lot this year. You start with it now, you see it around mid-year, and then we're going to see it come back again at the end. So this is not something that's going to go away. We're going to review it now, obviously, but you got to get good at complete the square. The way we go from quadratic form, which is what this is, remember if there's an x squared and an x, to standard form is by completing the square. To do this, we group the first 2 terms together. If there's a number on the front of the x squared, we factor that out of both of the terms. Then we complete the square. So you would see something like a, and then x squared, and then whatever this is, x. And then we leave this space to fill in what's here. What goes there, okay, is you take the second term, divide it by 2, and square it. So before you do this here, to complete the square.
Can you go back to that last one again?
Yeah, sure. Hang on.
Second.
Let me get through this and then I'll go back. So to complete the square, to find that last term, we take b, divide it by 2, and square it. And then we add it into that space. And it says it here, but what you add to the parentheses, you have to subtract from the outside. So you subtract it from the outside. We'll walk through this process, but these are the steps. And then you'll factor it. It's going to be a perfect square trinomial at that point. You'll factor it, and your final answer should be in standard form, which is a parentheses x minus h squared plus k. All right, so first it says write this function in standard form, okay? Then identify the graph and go through all that stuff. So we're going to start with the complete the square part. First thing is, again, this is different from Algebra 2 because in Algebra 2, the y was on the other side, you added the k to the other side, so don't get confused. We're going to do everything on one side here because these are functions. Step 1 is group together the first 2 terms. So if I rewrite this, I get f of x equals x squared minus 14x. I'm going to leave a space for the term I'm going to add, and I'm going to bump the 54 to the outside. Then I take that 14, I'm going to divide it by 2 and then square it. It doesn't matter the sign because I always square it at the end. So I get 7 squared, which is 49. I'm going to add it inside the parentheses. To balance the equation, I have to subtract it from outside the parentheses. In Algebra 2, we added to both sides of the equations because there was a y on the other side. In function format, we add inside the parentheses, subtract outside the parentheses because we have to balance out this equation. Now what I just did is make the right side of my equation, what's in the parentheses there, a perfect square trinomial, which was the point of it. Positive 54 minus 49 is a negative 5. Positive, it's a positive 5. Now the goal was to make this a perfect square trinomial so that I can factor it. When we factor, we square root the first term, we square root the last term, we take the sign from the middle. Put it in parentheses and square it. So I square root, well, it's f of x. I square root x squared, which is x. I square root 49, which is 7. I take the sign from the middle with as a minus, put it in parentheses, square it, and don't forget the plus 5. This is now standard form. So now we're at where we were at the beginning of the last couple questions. Take this, find my vertex, which is 7, 5. Find my axis of symmetry, which is x equals 7. Find the x-intercepts. So I plug 0 in for y. Go to square root both sides, and here I get a negative square root. So there are none. I'm going to find my y-intercept too, but I'll tell you why it didn't ask for it, okay? Just because I'm going to need extra points anyways. So I get f of x equals 0 minus 7 squared plus 5. Negative 7 squared is 49 plus 5, which is 54. That's why the directions here didn't say to find the y-intercept, because that's way off the graph. But it says to graph it. As of right now, I only have my 7, 5 vertex and an axis of symmetry at x equals 7. I know it. Yes.
So how come there's no x-intercept?
Because you can't square root a negative 5. It should make sense, Sai, if you think about what we're about to graph, because if there's a parabola that has a vertex where it is, and it points up because it's a positive x squared, my graph is going to look something like this. So it doesn't cross the x-axis. So as is, I don't have enough information to plot. I'm going to suggest not plotting your y-intercept, which is all the way up here at 0.54, okay? But simply plugging in some additional points. So let's say I go back to and right to. If I plug in 5, I get f of x equals 5 minus 7 squared plus 5. Negative 2 squared plus 5, which is 4 plus 5. That's 9. And if I plug in 2 to the right, it should be the same answer. F of x equals 9 minus 7 squared plus 5, 2 squared plus 5, 4 plus 5, which is 9. Now I know what my parabola should look like. So I'm going to say it again, but you need 3 points to plot a parabola. You need 1 vertex, 1 point to the left, and 1 point to the right. If your y-intercept was able to be graphed on this graph, that can count as one of your points. But I would have still had to plot something on the right side of my graph.
Miss Chris Weiser?
Yes.
When you show the work, when you plug in the 5, since you know it's a parabola and the opposite side would also be a 9, do you have to show the work for plugging in the 7 or no?
So I would say for homework, you're probably safe to keep it the way that it is without having to do both. But I would keep in mind that if I'm taking a test or a quiz on this, I'm going to plug in that second point to make sure I'm right.
Okay.
Right? If nothing else, it helps you confirm that the other point's right. Because if you did the math wrong on the first one, it's going to be reflected wrong.
Mm-hmm. Okay.
Any other questions on that one? I'm going to stop. We're not going to move on to the next topic, but I want to, because so that you can start your homework. Talk about what happens if I have a function. Okay, let's say I have a function that's like this, that has a number on the front of the parentheses. Okay, so when I get this in a standard form, I would put these in parentheses, okay? I would have to take out a 2. Now, when you take out the 2, it comes off the x squared. It also comes off the 5. Then I leave my space, and the 3's on the outside. Now I have 5 halves divided by 2, which is the same thing as multiplying by a half, and then squared. I get 5 fourths. 5 fourths squared is 25 sixteenths, and that's what I have to add here. Normally I subtract it from out here, but before you do that, you have to multiply it by the 2 you took out. So if you take a number out before you add it outside the parentheses, or subtract it outside the parentheses, sorry, you have to multiply it times the number on the front. So this would become 25/8, and I'd have to subtract 25/8 from 3, which is 24/8. And I end up with 2, I'll come back to this, minus 1/8. Then I square root the first term, square root the last term, take the sign from the middle term, put it in the parentheses and square it. And that would be my standard form. They're gonna get ugly, folks. You gotta be okay with it. I would say one more variation on that is if the 2 was negative. So same numbers, group these. This time I have to take out a -2. Now I have to take that 5/2, the sign doesn't matter yet, divide it by 2, which is multiply by a half, square it, I get 5/4 again, square it, 25/16. I add it in here, and I subtract it from out here, but I have to multiply this time times a -2. So instead of subtracting 25/8, I'm actually going to add 25/8. So 24/8 plus 25/8. Now when I go to graph that, this is 6 1/8. Okay, so keep that in mind. Obviously, you're going to be dealing with fractions. You will have one question on your test or quiz, at least, that has just complete the square. Then you can choose from there on out, do I want to take something that's quadratic, complete the square, or do I want to do what I'm going to show you tomorrow, which is like the negative this process here, okay, where you keep it in terms of the original quadratic form. -b/2a gets you your x coordinate, plug it back in, get the y coordinate. So there's a lot of ways to approach this stuff. I'm going to stop here. My recommendation is that you start the homework for WebAssign. It's not due till Wednesday, but if you save it for tomorrow, don't whine to me about the amount of time you're spending on that homework because it's going to be long, okay? There's a lot of questions on it, and these take some time. So my advice is get a head start. Let me look at it now, and I'll tell you what number you can get to. Some of them say use a graphing utility and some of them do not. Okay, so you can get all the way through number 6 from where we left off, and then there's not much left to do. Actually, you can get through number 8. There's 2 maybe that are applications, 6 and 7 that we haven't gotten to. The rest of them you could probably get to from what we have. So just make sure that you know what you're doing when it comes to complete the square and graphing up to this point, and then we'll finish it tomorrow. All right, people.